Right, hello grade 11. So as you can tell, I'm just so excited. I got my, no, too much of the excitement, right? Too much. Okay, so after we've made it maths.
Go away. Okay. Oh man. Oh yeah. So here we are. So again, keep an eye out for common factors. So kind of as we're getting a feel for these, we start going, well, we've got kind of divide by cos theta might be one thing. We might need to factorize. That's all we did in the previous question. If you remember, we changed this here and then we factorized our trinomial. So factorizing a trinomial, well, factorizing a common factor is a whole lot easier because what is the common factor on the left-hand side here? Well, I see a tan theta coming up in both of those terms. So tan theta sine 2 theta minus 1 equals 0. Now, it already equals 0. So this is why we could do the common factor. Or not why, but why it's useful to do the common factor. Because now we've got something times something equals 0, which means the first something must be 0. Or the second something must be 0. And that second something is sine 2 theta minus 1 equals 0. This purple one here, this one here, sine 2 theta. What's the effect of the 2? And therefore, what's the period of sine 2 theta? Well, I know that I've asked this question a few times, but I just want to keep reinforcing it well, the period is 180 because it's happening twice as quickly. So therefore, we're really expecting something, like there must be a plus one day I'll learn to write, plus 180k, right? I don't know. I'm just kind of half expecting that because of that sine 2 theta. But let's see. Maybe it doesn't come up. So for the first part, so now we can forget all of that and go tan theta equals 0. Well, when is tan theta equal to 0? Well, that was a badly worded question in some ways because when is it? Well, you could have given infinitely many answers. But with a bit of luck, you kind of got in your mind somewhere the idea of, well, tan theta, I know these things there. So it's going to be 0 there. And I know that there are these asymptotes every so often. And therefore, if we kept drawing this, there's going to be that 0 that happens every 180 because that's the period of tan theta. So there we've got at 0 and then again at 180 or there. So theta over here must be 0 degrees. Or we can keep adding 180 or subtracting 180. So therefore plus 180k. Or our second answer, well, I've already got the or, I guess, sine 2 theta equals 1. Now again, I'm kind of hoping that you go, okay, well, I know what sine theta looks like, so I sort of know what sine 2 theta looks like. So I'm actually just going to move this because I want a bit of space. And I'm going to kind of draw this over here to go, well, sine 2 theta looks like that, and it's going... You'd think that I could draw these graphs by now, wouldn't you? No. Well, I'll back myself one day, I'll learn. So let's see. I guess it just requires a bit more concentration than going all speedily. Okay, there we go. That's not too bad. It's a little bit on an incline. But, when is this equal to 1? Well, the highest point along here is at 1. So instead of, we're not thinking, some sort of reference angle and shift. When we see these special numbers of 0 and 1, well, let's just see, this is sine 2 theta. Already said that the period's every 180. So this point over here, if we looked at sine theta, so if we had sine theta in mind, sine theta would have gone like this, and that point there would have been at 90 degrees. And there would have been, this would have been over here. It's just repeating every 360. So at 90 degrees. But now this is happening twice as quickly. So this point over here isn't at 90 degrees. Where is this point now? Well, that point now is going to be at 45. Because look, sine of 2 times 45 is 1. Okay, so therefore that's 45. We already said that the period is every 180 degrees. So let's just say that theta equals 45. The period is 180. So 45 plus 180k. There we go, because there's going to be the next one, 180 degrees later. There's going to be the previous one, go back by 180 degrees. So that's why I wanted to look at that 180, and we kind of got that sense already. Because if we just kind of think, oh, well, reference angle, no, then we're going to be stuck. We always got these graphs in mind. So there's that one, and our last one. If we've got an equation like the one given here, pause, breathe, that's for me. Okay, so now that I've paused and I've breathed, yeah, then we've got cos 2 theta equals sine theta plus 10. We can't just divide this through by, oh, let's divide by, because if we wanted to create kind of a tan theta, we'd have to have cos 2 theta, but if we divided this by cos 2 theta, well, that's not tan theta because they're different. So let's look at this and say, well, the suggestion for something like this is that why don't we make them both sine theta or both cos theta? So if we remember, if we've got a freestanding right angle triangle and we've got, say, theta over here, what's this angle up top right here? Well, wouldn't that be 90 minus theta? So if this were, say, A, B, and C, maybe this helps us remember that, say, cos theta is sine of 90 minus theta, or, say, sine theta is cos of 90 minus theta. Now, normally we see those, you might just get told, oh, well, like cos of 50 is the same as sine of 40. It's something like that. They add up to 90. Okay, we know that. You probably just know those by now, but there's just our reasoning. Always nice to have. So therefore, if we keep the left-hand side cos 2 theta, let's look at our right-hand side and say, well, we want to write this in terms of cos instead of in terms of sine. So therefore, what am I going to put, or what are we going to put in the brackets here? Cos of what? Well, we're going to go 90 minus all of that, so that would be 80 minus theta. Now, you could either have thought about this as 90 minus theta plus 10, or just think those two need to add up to 90 degrees. So 80 plus 10 is 90, minus theta plus theta is 0, so you're left with 90. And I think that's a neat way of doing it, or you can do it algebraically. Okay, so if cos 2 theta equals cos 80 minus theta, we get a picture that looks not like that. Like cos 2 theta is sine x plus 10, looks something like that, and the intersected are all of these points over here. Looks kind of quite interesting, right? They're our points. So at A, they're going to meet B, C, and D. So there's maybe just an idea of what this is going to look like. I don't know, just for interest's sake, take it in. Got it in, I like it. So let's get back here and say, so 2 theta must equal 80 minus theta, right? They must surely be equal to each other. That feels like one solution set we're going to get. And that's going to repeat itself every 360 degrees. So 360k. Because remember, we're still going to account for this 2 theta and the 180. So this solution is going to repeat every 360. If 2 theta is the same as that. So if we solve our equation here, 3 theta equals 80 plus 360k. And therefore 80 degrees. Therefore theta equals 80 over 3, and we get our friend out here, and our friend says 80 divided by 3 is 26 2/3 degrees plus 120k, because we divided our equation through by 3. Okay, so there's our one set of solutions. They're going to be 3 solutions kind of every 360 degrees. So let's go back to here and see, okay, that looks like it relates to point A, because that's at 26 2/3. Then it's going to be plus another 120 degrees at B. Then we're going to plus another 120 degrees and we'll be at point C. So within 360, we've got that. What we haven't accounted for is this solution down here, D. You see this one? Let's make it, maybe you can't see it. That one there. Jump out at us, D, jump out at us. There it is there. So it looks like there's another solution that's at D. And look, it's going to repeat itself every 360. So there's another solution down there behind my head. But the graph, and why I just wanted to pull up the graph, is to say, well, there's another solution here. So the question is, where is our other solution? So maybe just jot down if you've got an idea. I'm going to put down my or so long. So or, how are we going to find our other solution? Okay, well, there must surely be a lot of different ways that you're going to say there. And yeah, I wish we were in class, and maybe I'll see a way of how we can share that thinking that you've just jotted down, because each of you are going to kind of explain in a different way and do something slightly different. So my way of thinking of this, and I say that quite carefully, and you know that I say this because there are going to be a few different ways. One way that I'm looking at this now is to go, well, let's just think back to our beloved cast diagram, just because I find it a useful little crutch. Just say, well, if we've got these two things, 2 theta and 80 minus theta, we always consider the two solutions we've got. So by putting them equal to each other, it's like we've looked in the first quadrant. But now, these two cos diagrams, there's always that second set of solutions within 0 to 360 degrees. So our second set of solutions must surely be down here, because cos is, it's like it's where it's positive. And that's why I say this is just kind of a crutch way of thinking about it, baby. You know, we've got this first solution where these two could be in this quadrant or in that quadrant. So using that thinking, and I'm just going to follow through the one set of thinking, but in our next class, please bring your ideas and those ones that you just wrote down to think of where that other solution set lies. So using this idea, this would be the same cos theta. So maybe let me scroll down because that'll be useful. Maybe our second idea is, well, we know that cos theta is the same as, whoopsie, whoop, and everything's disappearing. We'll be back. There we go. Okay. So I just wanted to undo. Cos theta is the same as cos of negative theta, right? So we've at the moment considered that obviously cos theta is the same as cos theta. So if that's the same as that, but cos theta is also cos of negative theta. So we could just as well have said, and that's where this kind of quadrant idea comes in, that 2 theta could be negative of the other angle, plus 360k. Just from our kind of knowledge here that cos theta is the same as cos of negative theta. So we could simplify that and go 2 theta equals, well, negative 80 negative theta, that's theta minus 80 plus 360k. Almost feels like a switcheroo. So if we solve this equation, theta equals negative 80 plus 360k. And that kind of matches there. If we went backwards, there's our negative 80 down there, and we could add 360 and get up to this point over here. Okay, so that would be one way of looking at it. Another way of looking at this same, and I do want to show both because I think we've done both now. Another way of looking at that is to go, we also know that cos theta is the same as cos of 360 minus theta. So another way of creating the same second solution is to say that 2 theta equals 360 minus the other angle plus 360k. So we're saying that either these two angles here, let's highlight them. So I'm just going to do this so that we can highlight them nicely. either that angle must be exactly the same as that angle, or this angle must be the negative version of that angle, because of cos theta equals negative, or cos of negative theta. Alternatively, this angle could be the same as 360 minus that angle. So by way of example, we know that, that's terrible, that, we know, I want to keep this train of thought, that say cos of 20 degrees is the same as cos of 340 degrees, right? But we also know that the yellow version was cos of 20 degrees is also the same as cos of negative 20 degrees. We're using those ideas. So if we solve this equation, 2 theta equals 360 minus 80 is 280 minus theta plus 360k. So subtract theta from each side. Theta equals 280 plus 360k. Now clearly these two things in these two rectangles are just two versions of the same answer. Because if you go negative 80 plus 360, you get to 280. It does not matter which one you do, if you go for option 1 or option 2. If you think about it as negative that angle, or if you think of 360 minus. If you have a preference, which one do you prefer doing? Option 1 or option 2? Okay, this is one of those ones like we're doing class to go, put your hand up which direction, because it doesn't matter, like it's just interesting to see which one you want. It's useful to understand both, but you're probably going to stick with one and go for it from here. So there are kind of your two ways of doing it. So therefore we've got our two solutions. We've got, well, this rectangle here showed us our one solution. So if I highlight in green, there's our one answer there. Theta is 26 2/3 degrees plus 120. Or either of these two, whichever version you prefer. Okay, so there we go. As always, just trying to give it a little bit of depth and just thinking beyond going, okay, run through the steps. You've got a few of these to practice in exercise 8. The traps, there are 2 of them. Those are going to be optional videos for you to watch if and when you want. But for now, I think you need to make it maths, of course. So enjoy, and goodbye.